Hello, everybody. Welcome back from lunch. No siestas. I'm watching y'all. My name is Pandy Knight. I am also known as the Automation Panda. I'm very grateful to be back here in one of the greatest states in the Union, Texas. So thank you, PyTexas, for welcoming me back to speak. If you remember last year, I was suffering pneumonia. I am no longer, so this is going to be much more energetic than last year. Let's do it. So, the million-dollar question, are API tests overrated? Oh, it's going to be one of them spicy talks. How many folks have done API testing? Raise your hand. I am so sorry. Me too, right? It's pretty common. You know, we say it is such an important thing to do, get that middle layer, but I don't know how valuable they actually might be. What? The testing guy is saying it's not good to do API testing? Let's unpack this. So, when we talk about API testing in a traditional sense, what we're talking about is the request, receive, ratify pattern. You can see here how we have a basic diagram of how tests would test APIs. You have your test automation process. It forms some kind of request. Get the status. Step one, request. Send it out to this web service. Web service, big old black box, does something with it, spits out a response. Their test automation receives the response. Let's say it's 200 OK for the status thing. Then once the test automation gets this response, it has to parse through it and perform assertions to ratify that the expected answer was received. Request, receive, ratify. Kind of follows the range act assert if you've heard that one. This is the nuts and bolts of traditional API testing. You have a live service, you hit it, you see what you get. This has been historically a major component of the testing pyramid, which I'm sure many of you have probably seen. And the idea behind the testing pyramid was in ancient times that you would want to shape your test strategy like this, where you'd have a bunch of unit tests at the bottom, strong base of unit tests. They're great, they're easy, they're small, they have very clear coverage, they run really fast. And then you go up the pyramid, you want to have some API tests. API tests are still good, they're still programmatic, they're still fairly quick. They're mostly reliable and direct, though you do have a network hop, so it takes a little longer, and they're a little more complicated to get the environments up. And at the top of the testing pyramid, you say, oh, UI tests, those are bad. Why are they bad? Because Selenium. No, Selenium's fine, it's the way you use it. But there was this perception that UI tests were bad because they were complicated and they were flaky. And we never wanted to do those, did we? And so we had this pyramidal shape, and so API layers are still good citizens. They're in the middle, we want them, they're better than UI, but I'm like, ooh, is that really true? I don't know, man, let's find out. So what is an API? What's it stand for? Application Programming Interface, with emphasis on the interface. Friends, it's just a remote procedure protocol. Usually we use like HTTP, or sometimes we make it fancy with REST, or the same thing, right? But it's just a protocol. It's a way we call things to do things. So if we really think about it, do we really want to test that API itself? Do we really want to test the interface? I would posit that perhaps we really want to test more what's behind the API. Right? The API is the delivery mechanism to get us to the inner business logic. We don't really, there could be a case to be made for testing the mechanics of all that, but really, in most cases, what we want to test are what's behind these APIs that we're building. And this gets to this idea of domain-driven design. This is something that I have learned about in more recent years and been like, wow, third eyes opening and big thoughts about software architecture and design. But ultimately, with domain-driven design, what we're saying is we want to have at the core of everything we do our business logic, because that's what solves the problems and gets things done. Everything else is just a port or an adapter to get into that. So APIs are just a mechanism to get into that core business logic that we're trying to really build to deliver value to our customers, because that's what we're here to do. We're here to solve problems and help people. So let's take a second look at what a web service actually is. Here's a fairly black box view. Pardon me, I love Dr. Pepper. So, not just a test, but any client can make requests, right? You structure them, HTTP, whatever, put headers on there. There's a HTTP method, you want to get something, you want to post something, whatever. There's a resource path that points to exactly what that endpoint is going to be. You send it off to the web service, and it does something internally, right? And it gives you the answer out, and the client receives that and then moves forward with its business. But web services aren't black boxes. There's a lot of stuff actually going inside of the web service. Oh, cool. So what's inside a web service? Well, first of all, we have a router. The router receives the requests coming in from the outside and ties them together to be like, oh, you made a get status request. Let me look that up in my table of all the things I could possibly do on my web service. Boom, gotcha. Then what does it do? Router says, I'm gonna dispatch you over to this handler. Boom, and that's where we see what's next. Handler might also be called a controller. I'm not gonna nuance the differences. Let's just say they're mostly the same. But basically, a handler is like a callback function or method to say, you made this request, let me get that thing and split it apart and see what you wanna do. And so in the handler logic, lots of times you might have like pulling out the parameters, pulling out headers, doing some parsing of the body, and ultimately the handler is going to take all of that and say, you wanted to do this operation. In this case, you wanted to get the status of this service. So then, if you're doing good practice like domain-driven design and separation of concerns, you will then have the handler call a deeper service layer. Yes, reuse of terms, kind of annoying. But a service layer, also called your domain layer or your business logic layer, is the thing where you actually get things done, right? You don't want to have any of that pesky like routing handling or parsing going on here. The service layer is like, I'm down to business. So what are we doing in this one? Okay, well, we're going to determine if we are good or not and send the response back. So service does its thing. And service layer could be things like it's entering rows in your database, or it could be pushing forward business process, or I don't know, we just saw this cool thing about temporal doing all sorts of distributed system stuff. I don't know, could be doing any of that cool stuff. Service is done, sends some information back, handler takes that, does a little more parsing and smacking, puts together a request, you usually have a builder for that, and sends it back, right? And so a web service is not necessarily just a black box. There are subsystems in here. In modern times, we have web frameworks to handle most of this, don't we? In Python, we have Django, we have Flask, we have Fast API. There's all kinds of ones that are awesome. But ultimately, what does the web service handle? It handles much of what the router and that table and the response crafting is all about. It's fairly boilerplate. Like HTTP doesn't change very much, right? It's kind of a fixed standard. And so we build these web frameworks to basically handle a lot of these concerns more abstractly. So wherein is the unique stuff that we really need to focus on testing? It's at the handler level. It's at the service level. It's all that stuff beneath that. That's where the value of what we're delivering is put. And so therefore, that's where the risk of something going wrong is most felt, right? So where do you think we should be putting our testing efforts? Much more on that handler and service side. So here is a fully functional web app written in Python with Flask. Ta-da! Isn't Flask awesome? Now, I think this is a Python crowd, right? We all get this. We're like, Flask, that's so many years old now. Well, yeah, we get it. It's cool. It's micro framework, right? Keep in mind, I am also in the testing community, and I speak a lot to folks who are not necessarily Pythonistas, but have more of that traditional QA background. When they see a web service, they still see this. They don't fully understand what goes on inside. They understand what comes out of it. But I think from my experience, most of them don't fully understand how easy it can be to pick up a web framework and make something happen. I don't think they quite understand how all that routing and handling stuff, that's mostly boilerplate now. And so without that understanding, you might think, well, of course, the whole big black box thing is what we need. But if you start to peel back the layers of that onion, you're like, oh, maybe we don't need to do that as much. And so here would be an example of taking that Flask app and turning it into a handler unit test. What's really nice about Flask is it actually has a testing client, so that instead of having to throw up a live instance of Flask, it actually does it internally, and then you can directly call as if it were like an API. You can see like the client gets status, but it's actually an internal thing. It's all local. It's like a unit white box test. And so this was a trivial example, but where this could be really powerful is like you can basically make very large tests for your web service internals, and you don't even need to use the Flask client. If you had other classes and methods, like at that service layer, you could just directly unit test those without any of this, right? Very, very powerful. So we have a lot of advantages here for these unit tests, because instead of having that middle layer, we've pushed those middle layer tests of the pyramid down to unit level. These tests are arguably easier to write, faster to run, closer to the code. They are automated inherently by nature, right? We're not getting in there poking around in something like Postman manually. And we've removed the network concern, right? What's the network challenge? You're trying to get a thing from A to B. What happens? It might not make it there. We've eliminated that, right? So now our tests are much faster and much more reliable. Wow, that's awesome. Look at all that risk we mitigated. But you might be skeptical. You're like, hold on now, partner. Yes, it's very important to get all that business layer, domain logic tested, and I can understand why you want to do that. But what if we need to test the connections, right? I don't have assurance that in this particular strategy, if I call it, it's actually going to come back and give me the response. There's still some risk here, and this is particularly risky with the following situations. What if the API specs change on me? Oh, crap, right? Your internal business logic might be the same, but the way it shakes hands might break, and therefore the whole system would be broken. Or what if the internals botched the HTTP calls for some reason? Now that's more of a concern of the web framework, which you would hope would be tested, but that's not something that we should be concerned about. Or another case of what if I have a bunch of microservices calling microservices, right? Because microservice, all the things, right? You have all these services pinging off of each other, and so now you have this giant mesh where one little change here can ripple tidal waves across your whole ecosystem. This is a valid concern. How many of y'all have a smoke alarm in your house? Raise your hand. Hopefully, Texas has fire code, right? I know we do in North Carolina. Great. Okay, cool. Did you know you're supposed to test that thing like once a month? Who actually does? Go Heather, my champion. Yes, I don't. But if you were to test it, how would you test it? You would press the button, right? Are you going to set your house on fire to test it? No, you're going to press the button because that's the contract by which you can guarantee, button press, ears hurt, run out, system works, right? No, of course, we don't need to make everything an end-to-end test. We don't need to set our house on fire just to test a small thing. So why would we do that with our APIs? Here is where something very helpful called contract testing comes into place. And this is particularly useful when you have a huge microservice ecosystem. The thought behind contract testing is to say, hey, instead of having tests of traditional style where you're just making request, receive, ratify, why don't we have those requests originate from the consumers, which might be multifaceted throughout our ecosystem, right? It's one thing to have a dummy consumer that doesn't actually exist. It's another thing to say, we have 7 consuming services that use us. Turn those into our testers, right? Because they're the ones who actually care when you change something. And what matters is that when you change something, it can be caught very quickly, and things can be fixed. So with consumer-driven contract testing, what we're doing is we're going to set up the consumers to work with a provider mock, and the mock is supposed to model what the consumer expects from the provider service. And on the consumer side, they can write all kinds of unit and integration tests on their side using this mock. And so that, at that point, becomes a white box unit test. We've gone down the layers of the stack again. We've removed that dependency that can be flaky. And we can very quickly see if the consumer is working with their expected side of the contract. Then what we can do is we can have this contract testing framework, like PACT, take all of those provider mocks from the consumers, send them over to the provider side, and the provider can make sure that it's actually serving up according to what the consumers expect. And so what this is, it rapidly makes sure that you're always in compliance, right? And so if you have multiple teams doing multiple things, you're the provider team, you're like, I want to make a little change here. Is this going to affect anybody? Well, this is a quick way to say you have 7 consumers, you make this change, it all works, you're good. Or if you blow up 3 of them, whoa, don't send that to prod quite yet. Go have a conversation with that team, right? And so here's what packed contract testing can look like in Python, because it has a binding for Python, right? On the left, we have a consumer test, and I know the text might be a little small here, but what we're going to do is we're going to say your consumer has a pact with your provider, and it's a status provider, because we're still doing that status example. In the test for get status, we're going to define the expected interaction. Packed, given the status endpoint is available, upon receiving a request for status, that's all kind of documentative. Here's where magic comes in. With this particular request, it will respond with this body, right? And now what you can do is with that packed, you can run all of your unit integration tests, and it uses that mock instead. This is a rather trivial example because it just calls request to get the thing and get back. But think about the case where it's like you have separated concerns, you have dependency injection, you maybe have client classes that are calling things, and you have other classes calling those client classes, calling the APIs. And so this mocking goes all the way through and keeps it clean. So you've taken all of this now, again, down to arguably unit level, depending on how you've implemented. Very fast, very reliable, don't need to worry about setting up all sorts of crazy microservices left and right in environments. On the provider side, what we're seeing is similar kind of testing thing where it's going to start your provider. On the other side of this, you're going to have all those contract tests from the consumers have to go over to the provider team. That's not shown here in the code. That's just something you're going to have to do as agreements between teams. But anyway, you're going to start up your provider, and it's going to hit against all the providers or all the consumer tests that you have, like that. So you can flush out these things pretty quick. So far we have put unit tests on the internals to make sure that's good, so that business logic is good. And now we've addressed the concern of handshakes, making sure A can talk to B and nobody gets mad when they change. Cool, all right. So, do we still need API tests at all here? We've got 2 of the stages of the flow covered and risk mitigated. But arguably, we still don't have an end-to-end flow, right? It's one thing to say, you can shake hands. It's another thing to say the business logic works inside, but we still haven't gone from actually like A to B and back again. There's still some risks that something might not be lined up. And so you might be like, well, I would still want to have these long chains of API calls to perform these workloads. Because aren't API tests still better than UI tests? Right, UI tests are bad, right? They're at the top of that pyramid. We don't want none of that. I still want to have my traditional API tests. Friends, I'm going to give you some reality checks here. No. End-to-end testing from human-facing interfaces is arguably the most valuable kind of testing there is. Thank you, Moshe. What? Scandalous, right? Think about it. Who do we build software for? People. Oh, right? If we build software for people, then maybe we should test it like people do. Oh, do people call APIs themselves? Not usually. Only us in this room. Does the rest of the world do that? No. They have a nice app on their phone. They have a nice website, right? Yeah, so we should be testing like people are actually using, because that is where we're going to catch real problems, right? Also, I would posit, UI testing is not as expensive or risky as it has been in the past. We have awesome tools these days, like Playwright. It's easier than ever and faster than ever to get UI testing up and running in place. So the time to value for most teams who in the past have struggled getting this in place has shrunk dramatically. I mean, even more so. Like I know I love Playwright. I'm a Playwright ambassador. I've been playing around with the AI forward tooling in Playwright, the MCP, the CLI, the agents and stuff. I mean, it's just like, give me a test with this planner thing, and just go, and all of a sudden, like working Playwright code comes in about 3 minutes. I'm like, oh my gosh, it's beautiful, right? So it's not as painful to do UI testing anymore, and it's freaky fast, right? They have done a lot in terms of getting rid of the flakiness and increasing execution speed. And I would also argue APIs can become very complicated and brittle, right? It's one thing to be like, well, you didn't get the whole UI up there and have to do all the web page stuff. You could just like really, like lightning strike a HTTP request and get a response that might be quick. Not always. I used to work at Q2 eBanking. I know they're here in Austin. Anybody heard that company, the banking software? Yes, somebody, cool. I used to work there a long time ago. And so I worked on a commercial lending app called Precision Lender. And I had the same thought, because every single one of my tests needed a new opportunity in the system, right? It's like trying to do a deal or something. And so I'm like, okay, well, I would think in a testable system, there would be an endpoint for like, post new opportunity, and maybe put in some data, right? Anyone want to guess how large that JSON body was? 50,000 fields. I'm like, wow. And every release, they were changing different things in the assumption set. So it's like, there's no way test automation going to keep up with that. You know what was really easy? Log into page, navigate, click button. Done. Never broke. APIs aren't always your fast path when it comes to testing. Interesting. So let's say, we were talking about this order status, or the status page thing, right? Well, let's say that it's part of an app checking order status, and we have a status page here, right? You're checking if all your orders are okay or not okay, right? We could write a basic Playwright test in Python, mind you. This is all Python through and through, Python full stack testing, I love it. But here would be a fully functioning Playwright test in Python. PyTest, of course, because we all know PyTest is awesome. But you inject your page fixture, which Playwright gives you. You go to the particular page of your status page. You try to click on the locator, you make sure it's there, and then you make sure the assertion, the inner text is okay. Does that look terribly complicated to y'all? Nah. And you also have the superpowers of AI to help you build this now too, right? UI testing is not as difficult as it once was. So, looking back at that ancient pyramid, right, where we used to say, hey, we want unit tests and just a little bit of API tests and some UI tests at the top, like, I don't think this is particularly relevant anymore, right? We don't build pyramids anymore as a society, do we? They're ancient. No, what we build are skyscrapers. Yes, bam, right? And so what we see is that we still want unit tests. That's great. They're good. We still want some kind of API coverage, but maybe that should be more of like handler tests that get pushed to unit level. And for all the connections in between, maybe that's some contract testing. And we still want UI tests because we know that's the way that people actually use it. And we can do that pretty easily and fast with tools like Playwright. And so it's not so much a pyramid structure, but it's more of a figure out how many you need kind of thing. Roll your own strategy for what makes sense for you. And to recognize that all these different test types are actually good. There's no such thing as a bad test if it mitigates important risk. Right? And so I'll be real with y'all. I have done a lot in the past couple years. I have been a tester. I was an SDET for the longest time. I've been a developer, earned my capital D. I have been a product manager. Oh gosh, I still kind of am. I've led teams as a manager, and I took a weird turn into DevRel. I've been around the block in all these kinds of roles. I've been all three amigos. And I tell you what, man, I've wasted a lot of time on bad API tests. Has anybody else felt that pain? Where so many times myself and others on my team, it's felt like we've been fighting to get the API working more than we've actually been successfully testing, right? Ouch. So when I ask, are API tests overrated, I'm not being entirely facetious. So real quick as we wrap up here, here's some general advice for API testing. Number one, in everything, focus on testing the things that matter most, right? Test where humans touch the software and build fast feedback loops more than you're trying to fill certain automation quotas, right? We're building software to give value to people. We're building tests to give value to our development teams. Number two, when you are working with web services, use tools like OpenAPI and established web frameworks. Don't build your own. There's no need. These are established standards for APIs, and they also de-risk that communication layer, so we don't have as much risk there, and we don't have to focus as much testing there. And three, perform traditional API testing only when most necessary. If you're doing like public integration APIs, yeah, you probably still want to do the traditional thing there. But if you're doing more internal kind of stuff, I would recommend, hey, maybe consider some handler unit tests. Maybe consider contract testing. Maybe consider you don't need any of it and the UI test is good enough. And maybe some spot checking of APIs directly could still be valuable, right? I'm not here to push you in one way or the other in the extreme. I'm here to get you to think, right? Are API tests overrated? Maybe, so consider the alternatives. So that is my PyTexas talk for 2026. You've been an awesome audience. Thank you very much. I hope you learned something and have been challenged.
I think my new nickname for you now is going to be Pandy from the block.
What?
You know, because you said you've been around the block, so you're still Pandy from the block.
I suppose.
You used to have a little, now you have a lot. All right. Q&A time. Feel free to vote and add additional questions. I think Brad's going to be tagging stuff as we go through.
First question, do I love
lots
Dr.
and
Pepper?
lots
Yes.
of questions about UI testing, by the way, so
oh dear, sorry.
be prepared. And there's one really loaded question in here because I know you. It's going to be a loaded question.
Y'all are skewering me. Okay,
yeah.
Hit me.
All right, can UI mocking be simplified down to the unit test level?
UI mocking? Well, I guess if you're doing like, if you're testing individual components could be like UI units, and you can do some interesting stuff there with front-end frameworks. It's a little hairy, but it's doable. Full UI testing? I don't know, man. That sounds like a conversation after this.
All right, are there packages or frameworks that you think simplifies UI testing?
Yeah, PyTest plus Playwright all the way. Done.
Fine, Pandy, I'll use Playwright.
That's right, man. Get it done.
All right. Can your approach be extended to projects with UIs not crafted from web frameworks such as Qt?
Maybe. That would depend upon the frameworks in use.
And the platforms, I know from experience.
Yep.
If you're trying to test in Windows, there are APIs for that. If you are trying to test in Wayland on Linux, good luck. May the odds be ever in your favor.
Oy.
Can end-to-end tests, for end-to-end tests, can fuzzing API endpoints benefit from your approach?
Fuzzing API endpoints. Maybe. I would have to think longer about that. I don't have a good answer off the top of my head.
Okay, so if you asked that question, hit up Pandy on the side because you might have to explain a little bit more. What are your observations about the adoption of BDD and orgs where they fit in unit testing suites? This is the one I knew was going to be triggering for you.
They don't. BDD is not for unit testing. Given when then is for feature level testing, for acceptance testing, for more end-to-end kind of testing. Right? I would not use a Gherkin-based BDD framework given when then steps written out for unit tests specifically. I would say I would follow arrange act assert as a pattern, and I might even put in comments in unit test arrange act assert as paragraphs or given when then in paragraphs. But like using a full-blown BDD framework like Cucumber, Wreck and Roll for unit testing, no.
In my own experience, I found that Gherkin is a great language for expressing test even without using it with the BDD framework.
I agree with that.
I think unless you have non-developers developing your test, BDD is just kind of a useless extra layer.
Mm-hmm. Yeah.
So, is Blueprint easily testable?
What's Blueprint?
Thank you, I don't know either.
Okay.
Thought you might know.
Homework assignment number 2. What's Blueprint?
Okay, there we go. Okay, last one. When do you think API testing is worth it, if ever?
So there are a couple cases, like, and I'm going to say traditional API testing. Well, we just covered these alternatives always worth it. But in terms of traditional API testing, when is that worth it? I would say, if you have a general, publicly available API that anybody can hit, you probably want to do traditional API testing, right? If you have folks on your team or in your org who need to do API testing, who do not have these skill levels for these more advanced techniques because these are more developer oriented, and you have to use those folks, and there's reasons and those kinds of in place, then you might be stuck doing more traditional API testing. And you know what? That might be the okay answer too. Okay.
I know I said it was the last question, but I have one more that I'm going to ask that came in. Should developers test their own features?
Absolutely. Yes. Yes. Please test your stuff, folks. That's an easy one.
Yes. I'll amend to it, though. Should developers be the only one testing their features?
No.
There you go.
Quality is a team effort, friends. Hi-ya.
All right. Thank you, Pandy.